Hello again, this is another review, so this is something a bit more big and expensive. This is a switching system, so I'm going to review the switches that I've worked with so far and the chassis and the whole experience of sort of software and stuff, so this might be a little bit longer than our 10-minute limit, but I'll rush through as fast as I can. So the switching system we're using at the moment is a Pickering, and if you think about a general sort of test system or an instrument, quite often you want to multiplex lots of readings to an instrument or to several instruments. So you end up with something called a sparse multiplexer or a sparse mux. You can also get matrices and things like that, but essentially they're ways of designing systems that switch to each other. So I last used Pickering in 1995, and I used their System 10 stuff, and it was very nice. So this is a new system for us that we're building. This is this high voltage harness tester, which is an instrument. It can do 50 tests of a harness, or 50 cores, and it can measure them. I can measure them for continuity, and it does an installation test, essentially, is all it's doing. So for that we need some switchery, which I probably won't go into, but just quickly, if I work that out, I'll just draw what a multiplexer is. If I can find a pen. Boop. Let's go to the hardware only. So a multiplexer is, tell you what, let's use a Sharpie. Probably leak through onto my desk. So a multiplexer is one in, and then you have switches that go like that. So that this is a 1 to 4 multiplexer. We have an additional complication in that I want to do installation testing, which means you want it to also do this. So this is a specialist switch we've got called an M series switch, and the part number we're looking at currently is, if I bring up the screen, pop, is a 23 channel 1 pole multiplexer card. Okay, so let's bring him back in so we can have a look at the good bits and why I use Pickering. Boop. I like to use Pickering. So it's all very nicely designed. Obviously it's high voltage, so it's protected. So you take the top off and you can see there lots of high voltage relays. Pickering actually make the relays, their own maker relays. And one thing I have to say about Pickering, and I liked about them when I first used them, is they always put a spare relay in it, because they know that that's the thing that goes fut. So having a spare relay is really good. Actually, I think those may be the spares. Oh, I don't know. Anyway, the spares are good. It's good to have. So yeah, it's all very nice and neat. A nice instrument. So while I screw that back together, actually turn him off. What do I think of it? Don't want to do hot swapping. Let's have a quick look. So the other thing we're looking at is our chassis. It's an LXI chassis. It's PXI in form, but it is LXI. So you won't be able to buy a PXI instrument to put in this chassis, which is fine for me because you don't get PXI installation testers. And so far, the multimeters that you can get in PXI are very expensive, which is a bit of a shame. But you can get a PXI chassis, and these do work for PXI. So that's very nice and neat. Let me just do this final screws. Boop. And then, so you might say, oh, well, it's only a 1 to 23, so what I'm doing is linking the 23rd into the next 1 to 23, and then linking that into another similar part number, which is a 3 to 7 way multiplexer. Okay. So the other nice thing, and it actually caught me out, I couldn't get the switch working, it was chucking error messages, is that because it's high voltage, it's got an interlock. So this little LEMO here, don't know why I'm looking at the screen trying to do it. This LEMO here is your interlock. So you can actually wire that into your interlock system for the high voltage stuff. And that will actually isolate all the switches straight away. So it's actual nice hardware interlock. So the other aspect of this part number, so it's a 40-31-107-high. Let's have a look at him there. There he is. So he's a high, but I've got the high M, which allows me to close all the switches if I want to. So the high is a standard multiplexer. You can only select one. So with this, I can actually select all of them, which is rather nice. Ow, just run over my toe. Oh, so let's bung that back in. Turn the thing back on. Let me turn my camera around so you can actually see my test setup here. So all this PXI rack, that's not mine. I'm borrowing it for another job. I will review it at some point. The Hioki, what I've already reviewed. This is a load of 100 mega ohm resistors wired in a fault condition on the last one. So I can actually test for faults quite easily on my test system. Let's have a quick look at the software. Okay, so I don't need to look at that. So let's have a look at the software. So let's do Windowsy stuff first. So here you get a load of Pickering drivers and the like. So you get a front panel, which is all quite nice. Hopefully he's going to find the instrument. There he is. So now you can do all sorts of things. You can see you can unclose switches and all sorts of nice stuff. So you get a little bit of help like that. So it's all free software. And it comes with a multitude of different types of drivers. Let me bring him up. If I go Pickering, drivers, boop. Download. So this is their website. It's pretty good. You do have to log in for some of the manuals and the like, which is always annoying, but it's pretty good. So you get a wealth of drivers, rather too many to be quite honest with you. So here's all the, and you can see it does IVI, does everything like that. Now, me being me, I don't want any of that. I just want to talk to it using Visa. I just want to talk to it because I want my software to work in Linux and Windows, and I don't want to be carrying around lots of dependencies. And there's a little hidden thing called Pillmon, which you have to dig out from their support because it's not a generally known thing. And Pillmon is, there he is. It was originally, you send ASCII characters essentially. In short, you send ASCII characters and you get ASCII characters back, which is all you probably need for a switching system because you want to open a switch, close a switch, and know how many switches you've got, really, in the real world. So I don't need all the extra gubbins. So let's go and have a look at the system that's running the software, which is in Linux. This is going to run on a very small embedded computer. For now, it's running in a virtual machine. So I've got to remember the password because I'm running on so many systems at the moment. Oh, it's an LXI instrument. What does that mean? An LXI instrument means, if you tap in one of the rules of being an LXI instrument, is it should have a soft front panel of some description. So if I go 192, ooh, hello, what's happening to my keyboard here? Don't know what. Stop it. Yeah. 2. Don't know what that was. Oh, there he is, look. I've done this before. And you get a soft front panel. And that's quite nice too. It gives you all sorts of stuff. You have to get into security. So one thing with Pillmon, you have to get it has to be in secure mode because it's a part of the SSH sort of system. So you could use SSH to talk to it if you want. I am using Visa, but that doesn't matter. It works fine. It took me a while, but that is a new instrument, so that's fine too. Okay, let me just log out. Just so that for demo purposes, just so I don't run into any weird things, I'm just going to log out and log in as root. Not oot. I want to log in as root. Pop. And okay. So he'll log in as root, and then we can have a look at the Pillmon drivers and things like that. Again, if anyone's interested, I'm going to give the Pillmon drivers that I've written as open source. I don't believe in keeping these things to myself. I'm probably going to give them back to Pickering if they want them, or at least they know where I am if they have a customer that wants to do the same as me and doesn't like dependencies like I don't. I've got my mouse. I had a sinking feeling I'd lost my mouse. Sometimes does that with virtual machines. It's quite annoying. There we go. So this is the harness tester as it stands now. I'm gonna tell you. Oh no! Wait a minute. Let me kill that again. Be extra safe now, just because it's a demo and I don't want to cock it up. I have to pass through the RS-232 for the hierarchy. Let's try that again. Okay, must have catched it. That's cool. Okay, let's bring out the block diagram, just in case I have to hack it. Okay, no errors, which means it's picked up all the hardware. So if I change this to hardware small, you've seen this before. I've done a demo on my other site, which just shows you how to use it. It's on Latte Panda, which I will transfer over at some point as being a review. So here, if I do 9 cores, it's supposed to be on the touchscreen. Oh. If I do 9 cores, it will pass. It should pass. If I do the 10th core, I think the 10th core fails. So let's see if I'm true to my word. So here you can see it's doing continuity across each core, just making sure that the wiring is correct. It does testing across the and that's all passed. So that was it. That was the test doing, and if you looked at the hardware you would have seen it blinking and flashing and stuff. And if you do your maths, so low voltage installation is just like a pre-test, so it's 25 volts. If it fails that, it's pointless doing a high voltage installation. High voltage installation, but you can see that's 11 mega ohm. I've still got to put some limits and numbers and things on the screen, so forgive that. But you can see it's about 11 mega ohms, so that's 900 mega ohms in parallel if you wanted to do the calculation. And if I then go and make that a 10 core, that switches in a core that is short circuited down to earth. And you'll see here, quite nicely, it'll beep, 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 beep. Continuity will pass. And now it's failed. And now it'll go and look for the failure. Sadly, it's going to look right at the end. But you can see now it's measuring each of the 100 mega ohm resistors, and there's our failed one, which is just a short circuit. So that's it. That's the whole system. So essentially, apart from storing results and things like that into a database, that the system is pretty much done now, which is nice. So let's have a look at the code for the Pickering. Already done high. Going into here. So if I go, where's the mouse gone? This is when it's annoying. Virtual machines are annoying. Okay, well, I'll stick this. I stopped the video to tinker around with the settings. And what it was that the No machine wasn't grabbing the mouse input, which was causing LabVIEW to, and probably any other system that uses the mouse in its graphics, as it were, to throw it off. So now we can actually see the mouse. Hopefully you can see the mouse on screen. Yes, you can. So now what we can do is we go to initializing. We can have a look at our hardware. So in here we've got our high voltage switching, and that's our installation tester there. High voltage switching. So this is aimed at, so the abstraction layer here is aimed at the test system. So it's closing mux 1 to 50, open mux 1 to 50, blah 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 blah. Select. We'll have a multimeter eventually. Select installation tester, blah. So this is just doing the things I want a high voltage test system mux to do, or my high voltage test system mux to do. Beneath it is then the calls to that. Because I haven't got a multimeter, I've got rid of that one. So let's have a look at close switching. So here's my clue, which tells me what I should be switching where and when. So if it's 1 to 22, I select this card and I select this switch. And then you can see below here is a Pillmon driver. So the Pillmon driver, let's have a look at him. And he's much more low level. He's dealing directly with the Pickering switch. So here, when he initializes, he asks for his identity, sets him up, he asks for all the cards, lists all the cards, opens all the cards. Sorry, COA is open all cards. I should probably put a little label in there explaining what each one is. LS is list all the cards. Get all the card details. This is a select card command, so it's USL space the card number space the subunit. So they're split into subunits. So the 1 to 23 mux has only got one subunit. The 3 to 7 mux has got 3 subunits. So you just select the subunit you want, and that just selects the card to switch, and then you just close the switch, which is SC. Yeah, works very nicely. Like I say, I had to tinker around with the switching the permissions on the LXI on the chassis, but apart from that, it all worked very nicely. And it's going to be a very favourable review, this, because I struggled with a few aspects of this. So the first struggle was as I bounced them, I said, I don't want to use your drivers, and normally a company would go, well, you can't use our hardware then. But in this case, very helpful. It came back and they said, have you tried this? So then we tried that. Then I bumped into not reading the manual mode, so I didn't read the manual. And again, very patiently showed me what to do and took an interest in the project, and it's just direct emails, to a guy. Do you remember that as a method? And they were just a nice company. I like Pickering. They're a good company. They make nice stuff. It's thoughtful. Just simple things like having a spare relay on the board where possible. It makes a massive difference to when your machine's broke. A day or two's delivery of a piece of hardware is a machine down for a day or two, or you're cannibalizing another machine to do it. So all that kind of stuff is just really thoughtful, and nice design. And they've got a good range of stuff. They got go on their website and have a look. I'm not being paid for this, by the way, although I am being sent a free XL t-shirt at some point because we went to visit them. And that's very nice of them too. But yeah, no money has changed hands yet. And yeah, Pickering for your switches.